Hi guys, welcome to my YouTube channel. Today we are learning about total derivative. That is total derivative. In this we have many types, but as of now I'm teaching only the important question that is asked in the examination. In that the main type that is which is repeatedly asked is if u is equal to f of x by y by z and z by x, then prove that x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z, which is equal to 0. We should prove that this everything is equal to 0. Now we have in total derivative we have to convert the given function into a composite function. That is, the given function in the form of f of x comma y comma z, but we need to convert it to the composite function, that is p q r respectively. That is, u is equal to f of p comma q comma r. Hence we are converting the given function, that is this is the given function, into composite function. This is composite function where this is p is equal to x by y, q is equal to y by z, and r is equal to z by x. This is pqr. Now we have converted to pqr to xyz, which implies dou u by dou x comma dou u by dou y comma dou u by dou z. Here now we should differentiate dou u by dou x, that is dou u by dou x, which is equal to, as we have rewritten the functions into composite function, p tends to x by y, q tends to y by z, r tends to z by x. In the same way, total derivative says that dou u by dou p, that is first one, dou u by dou p into dou p by dou x. This is differentiation, partially differentiation in the composite function, like in the total derivative this is the formula, plus dou u by dou q into dou q by dou y, sorry dou x, because we are differentiating with respect to x, plus dou u by dou r into dou r by dou x. We are differentiating with respect to x, so dou u by dou p into dou p by dou x, dou u by dou q into dou u q by dou x, dou u by dou r into dou r by dou x. It is the chain of this differentiation chain. Now dou u by dou p, that is dou u by dou p, let us keep as it is, but dou p by dou x, we should differentiate this p with respect to x. With respect to x means this is p, what is the p, x by y, plus dou u by dou q, you keep it as it is, dou q, what is the value of q, y by z, plus dou u by dou r into dou by dou x of r, what is that r here, z by x, which is equal to, you keep it as it is, into, with respect to y, with respect to x it is 1 by y is constant here, dou x by dou x becomes 1, plus dou u by dou y dou q as it is into dou we should differentiate y by z with respect to x, but we have not having any x term here, so this tends to 0 because both are constant. If we differentiate constant, then the value is 0 plus dou u by dou r into, we have x here, z is constant, bring outside, 1 by x, differentiation of 1 by x is minus 1 by x square, that is minus 1 by, now dou u by dou x is equal to 1 by y into dou u by dou p, minus into plus becomes minus z by x square into dou u by dou r. Now what I will do, in question we have x into dou u by dou x. We have here dou u by dou x. I will multiply x on both the side. Then it becomes x into dou u by dou x, which is equal to x by y, because I am multiplying here also, dou u by dou p minus x into z by x square into dou u by dou r. Now x into dou u by dou x by y into dou u by dou p minus 1x, and here 1x gets cancelled. Now z by x into dou u by dou r. You keep this equation as equation number 1. Now y into dou u by dou y, in the same way as we have done for x, same here also, but only by symmetric you change the variables, that side. As we know that in x into dou u by dou x, equation number 1 says that x into dou x, like here you see, as we have x into dou u by dou x, x by y, okay, but here y into dou u by dou y, in you take y by z, like here becomes y by z into dou u by dou q minus, here we have x in the denominator, it becomes numerator. After x what will come? Y after that x y into dou u by dou p. This you take it as equation number 2. Now in the same way for z into dou u by dou z, here we have y by z, now it becomes z by x, z by x into dou u by dou r minus x by y becomes y by z into dou u by dou q. This is equation 3 because it is symmetric in nature, by symmetric in nature. Now adding 1, 2 and 3, that is x into dou u by dou y dou x plus y into dou u by dou y plus z into dou u by dou z, we need to get 0. Now x into dou u by dou x, that is equation number 1. Equation number 1 says that x by y into dou u by dou p minus z by x into dou u by dou r plus y into dou u by dou y, that is y by z into dou u by dou q minus x by y into dou u by dou p, here plus z into dou u by dou z says that z by x into dou u by dou r minus y by z into dou u by dou q. Now here we have x by y, here we have x by y into dou u by dou p into dou u by dou p. This both terms gets cancelled. Again, here you see minus z by x into dou u by dou r. Here plus z by x into dou u by dou r. This both gets cancelled. Plus y by z into dou u by dou q minus y by z into dou u by dou q. Opposite sign, this also gets cancelled. The remaining is 0. Hence, this is the RHS we need to prove.